Hello. So this is lecture 1, chapter 7, lists and tuples. We are going to see what are lists and what are tuples. Before I can do that, let me go ahead share my screen. I have already forked the REPL from my lecture handle. So go ahead, use @suchiroda handle and look for chapter 7, lists and tuples, and you can fork the REPL. So I've already done that. So what is a list and a tuple? A list and tuples are type of sequences in Python. So before I explain a Pythonic way, let me tell you a real life example. So if you have a wedding and you have guests arriving to your wedding, all to the same wedding, and they're all coming in different cars, and you want to keep up with where they are, when they're going to arrive, and what kind of arrangements you want to make, how difficult is it to know, because they're all coming differently at different times and different. But imagine if they were all coming in a bus or in a train, for example, together. It's easy for you. All you have to do is you have to know where the bus is at any given point of time, and you can know when all your guests are coming. So very similar to that, there are scenarios in our Python programming situations where you need to group data together. For example, our student data. Our student can have multiple pieces of data like name, major, GPA, and all of that. And up until now, we've been creating separate variables for them. But what if we just want to group all that data together and store it in a data structure because it is supposed to be together. So that is when we use a data structure that is sequential. So a sequence is an object in Python that can hold multiple items of data. So up until now, we've seen strings, integers, floats, and booleans. These are the primitive data types, but they could only hold one value at any given point of time. But what if we wanted to store more values? That is when we use sequence. And there are different sequences in Python, lists, tuples, sets, and dictionaries that we will be seeing in the next chapters. And each sequence is characterized by three different characteristics. Number one, order, mutability, and duplicity. And we will see what they are in detail much later on. But depending on order, mutability, and duplicity, we have to decide when to use a list, when to use a tuple or a set or a dictionary. So let's move on to see what is a list and what is a tuple. So in this chapter, we will look at those two data structures. And lists and tuples can contain any arbitrary number of elements of any data types. So not only are we storing multiple pieces of data, we're also storing multiple types of data. So one can be a string, one can be an integer, one can be a float, or any possible combination. So lists and tuples will allow you to store any number. There's no set number. Once you create a list, you can add as many elements throughout the duration of your program. The only difference between lists and tuples, actually not the only, one of the differences between lists and tuples is lists are mutable and tuples are immutable. So we have seen one of the characteristics being mutability. So what is mutable? Mutable means once you create the list, if you are able to add more elements and if you want to delete more elements, that is a list. Once you create a tuple and you cannot access those elements, or you can access those elements, but you cannot change those elements, you cannot delete those elements, then that is a tuple. That's a fundamental difference. There's one other difference, which is how lists and tuples are defined for Python. So let's get started and see how to create a list. So let's create an empty list first. So I'm going to do my def main, and then I'm going to do my path, and then I'm going to call main. So inside this main function body, I want to create an empty list. So if I want to convey my intent to Python that, hey, I want to store the scores of a student, and it's going to be more than one score. So I can tell Python that, hey, scores is a list. So by simply specifying open close square brackets, I'm telling Python that I intend to store multiple values here. Or another way is to do list open close parentheses. That's it, very simple. So this is not a function call. This is creating an object named scores of the class named list. So we have done very similar to this in our previous lectures when we wanted to create a string. We used the str class and we created an object. If we use int class, then we're creating an object of integer class. So very similarly, we're going to create a data structure called list, which is going to be empty right now. So if I print this course right now, Python will print open close empty brackets. Okay, I am not calling main, I'm just saying main, which is weird. So main. And then there we go. It prints open, close, square brackets. That is signifying that that's an empty list. Okay, now that doesn't do me much good. How can I create a list with elements? So that the syntax would be list name. You have to give it a name equal to square brackets. And then you have to specify your elements. All of them are separated by commas here. So these elements, element one, element two, can be of any data type. So let's get started and see in numbers. So we can print list elements. Okay, before I do that, I'm going to show print. So I have 5 elements here. Every single one of them is an integer, and that's why this is called an integer list. So I've given it the name even numbers equal to square brackets are open, but now they're not empty. Now they have 5 elements, each of them separated by commas. So when I print this using Python's default print statement or print function, Python will print all the elements. But I have written a friendly pretty print module, and you can look in your sidebar and you can see there's a Suchi pretty print. So that is my module that I have written, and we are going to use this for printing any sequences. This is really friendly. And instead of print, it's Suchi print, Suchi underscore print. So instead of Python's default print, if you use my print statement or print function, what is it going to print like? So, so it'll tell me this is a print module written by Suchi Rhoda, blah, blah, blah. So to use this module, and it is printing the list. So it is telling me, number one, it's telling me that even numbers is a list. Number two, it is telling me something here, and I will explain that to you in just a little bit what that means. But before that, why is my module printing all this gibberish? Because if you look at my module, I'm going to grab it here and place it with main. Okay, so this is the module that I have written, and all I really intend to use is this function. And there are multiple functions here, and I don't want to use all that. I just want to use print. But the reason why my module is printing all this is it is trying to call main, and main is printing all this. So that is why we as programmers are instructed to use what is called if underscore underscore name underscore underscore equal to int main underscore underscore, then only call main. So the reason why, if you have seen these code examples online, what it means is if the name of this file, so underscore underscore name underscore underscore is a built-in variable in Python that will retrieve the name of that particular file. So if you try to print name underscore underscore here, it'll print Suchi print py or Suchi underscore pre underscore print. So the reason why we have to do our modules here is whenever we're importing other people's module, we don't want to call their main. We just want to use any other functions that they may have worked on. So that's why this is the code convention that unless the main function is inside main.py, do not call it. So that is where this comes from. Every time we write this, that is conforming to Python's code logic, to where unless this function is inside main.py, if the name of the file, so if I print name underscore underscore, what is underscore underscore name underscore underscore? It simply prints the name. If I can, I'll just get it out of the indent, nothing, not inside main. So there we go. So it is printing main because main is the name of this file. It's not just main, it's underscore underscore main. So from now on, our code logic will be not a simple main call, but we're going to do this because if someone else is importing our module, we don't want them to call our main. They just want to be able to use the functions that we write. Okay, so moving forward. So, all right, so let's get back to our list. So the list is created. Even numbers refer to the data elements like this. So Python kind of creates like a structure, data structure like this that will sequentially store all of these data. And when I say sequentially, it'll store the addresses sequentially. These can be stored anywhere in the memory. But let's get into all that later, and I will get into this later, what 0, 1, 2, 3, 4 means. But for now, let's go on and create another list. So if you wanted to create a float list, how can we create an element, a list with all floating points? So if you want to store the sales data for something, for a store for 5 days, you can use floating point numbers, comma, and more. So these is 5 float point numbers, and when I print that, Python is going to give me all of these are floats, and then it's going to tell me the positions where they're stored, and we will see that later. If you want to create strings, you can also do that instead of. Now, all of these don't have to be the same data types. We can mix and match. You can have an int, you can have a string, boolean, all of these. And multiple data types would be when you have our dear old student example. So a student has a student ID, and that's an integer, and his name is a string, his major is a string, his GPA is a float, and also look at this, the last element is a list. So a list can have a combination of multiple data types, including a list. So I have a student whose scores are also stored in another list. So when I try to print this using my friendly module, if you look at it, it's going to tell me that these are all the data types that are available, and these are the positions in the list that they are stored. And if you can look at it, the fourth element, it is telling me that it's a list, and the first element of that list is 90, next one is 95, 67, so on and so forth. So we have seen clearly how to create an empty list and how to create a list with elements. So the important characteristic in lists are ordered. So if you go back and if you look earlier, we've talked about order, mutability, and duplicity. So let's see how lists can conform to that. And so lists are ordered. So what does that mean? So you have two lists, favorite actors. One is George Clooney, Tom Hanks, and Henry Cavill. Favorite actors two. Now this time Tom Hanks is here. Instead of in the second position, he's in the first position. And George Clooney, Henry, basically the elements, the actors are all the same. They're just ordered differently. So will Python consider these two lists the same or not? That is what determines whether order is important. So Python is telling me that these lists are not the same because even though they're the same elements, their order is not the same. So lists care about the order in which you're defining the elements. That is why they're not the same. So lists are ordered. That's number one characteristic. And duplicity is you can have same value appear multiple times. So if you define a list like this, Python will let you do it because this list, even though it has multiple values, 2 is appearing multiple times, 3 is appearing multiple times, the lists are allowing you to store that. That means that lists conform to the duplicity characteristic. There's another data structure that we'll see later on that will not allow you to create duplicate values. That is called a set. So, so lists are ordered, lists allow duplicate values, and lists are mutable. So all three checkboxes are checked for a list. So just let me pause for a second here. So we have seen how to create an empty list, how to create a list with values. Now we're going to see another way of creating a list using the range function. So if you remember when we were doing our for loops, we used the range function. Range is a function that generates a sequence of elements. So for example, if you have something like this. So if I didn't have this, if you just had the range function, range will generate a sequence of when you see 5, that means it starts from 0. So it generates 5 elements starting with 0. That will be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So that's the sequence. So I can use the list constructor to pass that as an argument. So I'm passing the range as an argument to list. And then when I print numbers, I'm going to do Python's default print, and it's going to print 0, 1, 2, 3, 4. And these square brackets signify that this is the list. Again, you can use my print statement also, and to see the indexes of those data elements. So there's a try this for you, and you can try that and see. And I'm not going to go over into range function because we have seen different variations of range before too. The only difference here is now we're using the list, open close parentheses, and passing this range as an argument to that. That's the only difference. So for example, if this were the range function, we started elements 1, we go on up to not 10, but 10 minus 1. So 1 through 9, we step every other elements. So we start with 1, 3, 7, so on and so forth, and you can look how that goes. So all the alternate numbers starting with 1 but not including 10 are going to be stored in this list. So that's another way we can create a list. Last way of creating a list that I'm going to show is using the repetition operator. So if you can remember, we used string to repeat a string, we simply did string times whatever number. So very similar to that, if you want to create a list with repeated elements, and lucky for us, strings lists are allow duplicate values. So for example, if I create a list named repeated underscore list, and inside the square brackets, I only give one element, but I'm telling Python times 6, Python is going to create 6 elements. All of them will be 7. So there we go. So that's another way to use the repeat operator. If you operate it on a string, it repeats that string. If you operate it on a list, it'll create that many elements of the list. So for example, instead of 7, I have 7, 6, 5, and then I repeat it 6 times. Python is going to create 3 times 6, 18 elements for me that will be repeated. So 765 is repeated each time. So now I've easily, in one step, created a list with 18 elements. So that's another way to create a list if you ever need to. So there's a try this for you to take a look at. And one thing you can remember, the number must be integer. So this 6 has to be an integer. You cannot use a string or something. So if the user gives me the number here, enter how many times. So if the user gives me this, I cannot simply do that. If I do that, Python is not going to like it. And even though I'm entering 6, it is because num is a string, so I have to convert it to an integer. So we have seen this when we were doing string repetition. So now if I give it 6, then it will create the repeated list. So that is one other thing to remember. So now let's jump into indexing. So we can access the individual elements in a list with an index. So now I'm coming to what do these numbers 0, 1, 2, 3, 4 on the left side, what do they even mean? They are the index position of an element. So just creating a list is not enough. I should be able to access those elements. That's the whole point. The ease to be able to access any data point, any piece of data is the original objective. So how can we access that? Using the index. So when we create a list, say something like this, and I call it row 1. So my list name is row 1, and it has 1, 2, 3, 4, 5 data elements. One of them is a string, another is a float, string, integer, float. Okay, so if I want to access, say, Facebook, how can I access this element? So that is going to be using an index. So Python uses index values to get these values. So the very first element in most most programming languages, the indexes start with 0. So if I do list name, which is here in this case is row 1, and open square brackets, and inside that if I just put an integer 0, and if I print that, inside a print statement, Python will simply print the word Facebook, or the very first element, because I'm giving it 0. Index 0 specifies the very first element of the list. Index 1 will specify the second. twos, we'll specify the third, so on and so forth. Because the indexes are starting from 0, we have to be careful how we word this. So that is how we can access any individual element using these square brackets. After the list name, you start with square brackets, and then you give it the index position. So right now we have 0, 1, 2, 3, 4. What if I give 5? So if I give an index position that doesn't exist, Python is going to say index error, list out of range. So we need to be careful whenever we're trying to access elements, we need to make sure that those indexes are actually available for us to access. So the next one is negative indexing. That's fine and great. Python uses positive indexes to denote elements from this side. But what if I wanted to get the last element? So I don't care how long the string is. I just want to get the last element of the string. Well, Python, I haven't seen this in very many programming languages, will give you a negative index, which means the last element. That's it. And then when you print, it's giving me 3.5. If I want to access the last but one element, then I would be using -2. So the second element from the last, so on and so forth. So you can access any element either from the beginning of the list or from the ending of the list. So that's the beauty of it. So you can look at this image and see if you have a list like this, the negative indexes go from -1. They don't go from 0. They go from -1 all the way to -5. But the positive indexes start at 0 and go all the way up to, in this case, 4. So we've seen what happens when you use an index that doesn't exist, an exception is raised. So you have to remember anytime you're doing in the square brackets and the index name, you have to make sure that that is available. So, all right. So accessing a list index using values. So now we're doing the opposite. So for example, we have a list like this. Okay. So earlier we knew the index and we were trying to print that, but what if I don't know the index but I know the name? Hey, I want to know where the word James Smith is in this list. So given a value, how can you get the index? That is using the index method, and I will show you first. So the position can be retrieved by using first the list name and a dot. And then as soon as you do that, Python will give you a list of all the methods available for this function, for this student object, which is an object of the class list. So list has all of these methods available. So we're going to find the one that is index. And then I'm going to give James Smith, and I'm going to print the position. So when I print it, it should give me 1 because that's where the index position is. So what will Python do if the case doesn't match? So earlier I just gave the exact word, but what if J is a lowercase? Then Python is not going to find, and also it's going to give me an exception. It raises an exception called value error and is saying James Smith is not in the list. So that is either we have to use an exception handling to handle the situation, or we have to do some sort of a fancy comparison. But thing to remember is this case has to exactly match if it's a string. If it's not a string, if it's an integer, that's great. Um, again, 1, 2, 3, 6, 7, 8. So it'll tell me where that index is, which is 0. But if it's not available in the list, then it's going to raise an exception. So that is another thing to remember. And how we handle this situation, we will see them later. So given the value, we know given the position how to retrieve the value. And we also know given the value how to retrieve the position. So I think this is about the end of this lecture, and then we'll see more in the next lecture. Hello, so this is lecture 2, chapter 7, lists and tuples. And in our previous lecture, we have seen how to create a list and how to access the elements of a list using the indexes positive and negative. So before I jump to the lecture today, I want to show you this cheat sheet, which is available to you on Moodle. And I want you to open and look at the very first sheet. So while we are learning our list operations and the Python methods and statements that we need to accomplish that task, we're going to fill out this cheat sheet. So for example, you would be for mutability under list. Yes, we have seen that lists are mutable. And again, you can print it and handwrite it. That's okay too. And yes, lists are ordered because they have to be in the same order to be considered same lists. And yes, you can store duplicate elements in a list. Okay, so that would be your how you would fill it. How to create an empty list? Well, you can create a list name L1 equal to or my list equal to what you name that variable is up to you. Or you can do my underscore list is equal to list. And how do we create a list with values? We can simply say my underscore list is equal to open close parentheses. And we have seen how to use um, comma separated values. So you can use different data types, or how you want to create your list is up to you. All I want to see is comma separated values. And how to find an element using an index and or an index or a key. We simply do my underscore list, and we're just going to say index. Example also, you can give my underscore list equal to 0 at 0 position, if I can spell it correctly. And that could be the example. So the index could be the index position 0, 1, 2, 3, 4, whatever. And I'm going to place a star here because star signifies if you try to access an index that doesn't exist in your list, it will raise an exception. So anything that could potentially raise an exception, I'm going to mark it. So find element using value, and we have seen all of those. So I want you to put all of those in this. So if for this, you would use the index method, and then you would give the value inside that. And you can also give an example of what that value could be from your list, or so on and so forth. So that's kind of how I want to see this list populated, this entire columns populated. As we go and see all these operations, I want to see how you would do it for a list, how you would do it for a tuple, and subsequently when we get to dictionaries and sets, how we accomplish all of these tasks in different data structures. So that will be a bird's eye view that you could use in your exam. So I'm going to stop the share, and I'm going to share my lecture video. So let's go. And all right, so in our previous lecture, we stopped at accessing the element using index positive and negative. So now next we're going to see how to add an element to a list. So once we have created a list, we know that lists are mutable, so you can add more elements. So the first thing is, how can you add an element at the end? So if you have a list like this, and I want to add something else, say the salary of this employee at the end, how would I do that? And I'm going to delete it so I can type it myself. So given a list named employee, first we have to use the list name, and then we have to put a dot, and then Python will give us all of these options, and one of them is append. Append literally means at the end add one more element. So to this we can give only one and only one element. So that element could be an integer, float, string, whatever. But if I want to add a salary and I want to give it an integral value, so this person's salary is an integer 70,000, I can simply append that value. So append will not take more than one element, one and only one. And then when you do that, and after that, if you try to print your list and see using my method, it will show you that it is added at the fifth element. So earlier it had only 5 elements and the index positions ended at 4. Now as a fifth or the sixth element at index position 5, it added a new integer 70,000. So if I put these 70,000 in double quotes or single quotes, my print statement will tell you that it's not an integer anymore, it's a string. So that's very friendly to know also the data type. So that is when you want to add it at the end. What if you wanted it at a specified location? You wanted to say add the salary here after HR instead of at the end. So how would you do that at a specified location? The syntax is using the list name instead of append. We're going to do insert, but insert will take 2 values. Okay, append only took 1 value. Insert will need 2 values. And what are those 2 values? It will need where do you want to insert? That means that after the insertion happens, this will be the new index position of this element. So right now, if I look at 3, 0, 1, 2, 3, 3 is actually something, a list of some values for that employee. But instead of that list, if I wanted 75,000, so pretty much it'll move the entire list to the right and insert this element in the middle. So all I have to do is specify where it wants it. And then when you run it, now at 3, you should see 75,000. And earlier 3 was a list of elements. So that is how you can add at a given position. So knowing this, if we can simply go add element at the end, you would do my underscore, go back to my PDF and I want to share that. And I can simply say add element at index, or at the end would be my underscore list dot append. And then we can give the value, whatever value that is. Or at the index position, you want to add, you want to do my dot list at insert, and then you want to give the index value and the value, 2 elements for index. So you can also give yourself examples of how to use these or so on. So after this point, I'm not going to show this PDF anymore. This is how we're going to fill this cheat sheet before you come to class. So stop share. I'm going to share my lecture screen again, and let's go on. All right, so we have seen adding elements. So what happens if you insert at, say, 10? So this list obviously doesn't have 10 elements. It only started off with 5 elements that started at index position 4. But what happens if you give insert 10? So will that create an exception or not? We're going to see that in a minute. So you would think that, oh, earlier, whenever we were trying to access index position 10, it raised an exception, but will insert raise an exception? No, when the index position doesn't exist, it will simply add it to the end. So that is one thing to remember, that if it doesn't exist in an insert method, if you use an index that is not available, it'll simply add it at the end. All right, so we have seen adding. How can we delete elements? So delete could be if you knew the value, how to delete it, or if you knew the index, how would you delete? So 2 different forms of delete. So if you know the value, so if given a list like this, a list of programming languages, if the user says, I want you to remove JavaScript, so if that's the value the user is providing you, then you can use a method called remove. So you have to use the list name dot, and then you use the remove, very simple English-like language, and specify what are you trying to remove. And again, the case has to exactly match. So if the user is giving you this all in lowercase, and if you're trying to remove it using that value, it won't work. So we will see all that later, how to handle that. But you need to remove JavaScript that has to be exactly case and matching with the case. So when you do that, it will remove that. And now your list is only 3 elements long with 0, 1, 2 as their index positions. But what if the user says, no, I want you to delete a value at a particular index? So when you're given the index instead of a value, how would you do that? So if the user gives you 3, how would you do that? We simply use what's called a del statement. So earlier, if you remember, we used the list name dot, so on and so forth. Up until now, we've seen list dot append, or list name dot insert, or list name dot remove, and those were all methods. But now we're using a statement called del. So we use del, and the program, and this is the name of the list and the index position you're wanting to delete. And that's as simple as that. Then it is going to delete whatever is in the 3rd position. So 0, 1, 2, 3. So the only problem is if you're trying to access something that doesn't exist and delete that, if the user gives you a value like 7, then you have to check before you try to delete, because this is going to raise an exception that's called index error, list assignment index out of range. So that is that. So there's a try and try that. And let's see. So in operator. So the best example of an in operator, before you try to do something, first check if is it in the list or not. So that is when we use what's called an in operator. And I have not seen any programming language that I know that you can simply check if an element is in the list without using a for loop. But Python is beautiful in the way that if you simply want to check something like this. So given a list, if you want to see if George Clooney is present in the list, because say for example, the user wants to delete George Clooney, okay? So we can use the method called remove. So let's do that first. Favorite actors dot remove, and then I'm going to give George Clooney. We've seen how to do that. And then we're going to print our list to make sure it actually worked. So here we go. So it deleted, fantastic. But what if I ask the user to give me that? So now when you're at the mercy of the user and you try to instead of remove George Clooney, now I'm going to tell, okay, whatever the user tells me, delete that. If you did that, and it'll be great if the user enters Tom Hanks because he's in the list. So here, Tom Hanks got deleted from the list. But if I run it again, and this time, if I give Brad Pitt, oh, there you go, value error. This is not in the list. So remember, the remove method raises an exception if either the case doesn't match or if the element is not found. So in this case, if I use an in operator, so if actor in favorite actors, a very simple English-like language. So we're trying to see if is this person even in there. If he's in there, then remove. Else, we're going to say actor not present, right? That'll give. So there you go. Now, if I try to give Brad Pitt, and Python is simply telling me actor not present instead of all this verbose description or the exception. So that's when we use in operator. Anytime you want to check before you perform an action that could potentially raise an exception, we check if that's even in the list. All right, so that's the in operator. Next is the len function. So remember, note the use of the words that I'm using here, that in is an operator, and here I said del is a statement, and I said remove is a method. Now we're going to see len is a function. Um, so what is a len function and what does it do? I'm going to leave my pass in there. Okay, so if you want to know how many elements are in your list, so that's when you use what's called a len, and we'll see why that could be significant. So for example, let's say the user wants to delete an element at the list, okay? So I'm going to say position, and I'm going to ask the user, hey, give me enter index to delete. So we're asking the user, you tell me what you want to delete and give me the index position and I will delete it. The only caveat is this index has to be an integer. So I'm going to go ahead and do my conversion right here. So the user is going to give me something and I'm going to use the del statement and I'm going to delete that position. And then if I try to print, okay, let me just do this for now. Or I'm going to go ahead and delete that. Let's not create a confusion. All right, so very simple. I have a list and I'm asking the user his give me an index that you want to delete and I'm deleting it. In a perfect world, if the user enters say 0, it should delete George Clooney, which it did. That's fantastic. But again, when you're at the mercy of the user, he could give you just about anything. And what if he gives you 10? And then it'll tell you index error, list assignment out of index. So this is when we can first check how long is the list in the first place, right? So that is what the len function does. So it'll tell us the length of the list, and len is a function, so you have to use len in parentheses. You're going to pass the list. So earlier, we were using the list name dot something, but here len is a function. That's why we're going to do len, and inside that we're passing favorite actors as an argument. So once we get the length, we will check if position less than or equal to less than length. Okay, cannot be equal to. Then only we're going to delete it. Otherwise, we're going to say else. We're going to say print not an available index. How about that? Okay. So now if I run my code and I ask index to delete is 10, now it's going to simply tell me it is not an available index. So that is why we always need to calculate. And again, it doesn't have to be in two separate statements. You can do it all in one, and there we go. Len function will calculate that number, and we're comparing it with whatever the user is giving us and saying, hey, anything right now, the length of the list is 1, 2, 3, 3. So anything less than 3 is okay. So, and again, you have to make sure that it is greater than 0 also. So you can also do that comparison. Greater than or equal to 0 and position less than. So anything between 0 and 2 is good. Otherwise, we're going to simply say available. That's when we use len function. All right, so let's see how to modify elements. Okay, so a list is already created. So for example, my favorites actor list is here. And the objective is to change the value at index position 2 to Tom Cruise. So 0, 1, 2. So given an index, if I want to change the value at that index, what I would do is I would simply use the list name, square brackets, and the index position in here, and then equal to, and assign it a new value. And that's it. And I print that list, it is going to print it like that. But that is given the index position. What if the user tells me, I want you to change Henry Cavill's name to Brad Pitt, for whatever reason? Then I don't know the index position. So now I have to figure out where the index is. So there's an additional step here. So this is when you know the position. What if you don't know the position, but you know the value? So the first order of business is find where it is. So to change the value of, say, Tom Hanks to Brad Pitt. So the first step is check if Tom Hanks is there in the first place. So that is what we have learned in the in operator. So if Tom Hanks in favorite actor, so if this person is in, then get the index. Where is he? First, see if he's there. If he's there, find where is he. And index is the method that gives us, and then I'm storing that in a value called position. Now that I know the index, I can do the same thing that I did earlier, use that in the square brackets, only this time it's a variable, and then change the value to the new value. That's about it. So let's start over and see, give the user the authority to do all of this. So name is equal to input, enter the old name. Okay, and also let's give new name, input, enter the new name. So we need to know what was the original name, and then we're going to also ask, what do you want me to change it to? So if name in favorite actors, first of all, is it even there? If it's not even there, let's not even bother. Okay, I think this would be a good idea to move this inside the if block. Only if the name there, then we're gonna, okay, I found the name, I need you to give me the new name. So I want to find where is the name in the list. So where is this variable in the list? I'm simply going to do favorite actors dot index, and then I'm going to give it the name. So whatever the user enters, look where is it in the index. It's obviously in the list. We know that for a fact. So where is it in the file, in the list? And then we're going to modify that by putting in the square brackets the POS, which is the position, and then give it the new name there. So what was the old name is now going to be replaced with new name. So let's try. So the old name, so I have to exactly match the case. So George Clooney, and then the new name. So it found it. That's why it's inside this if block. Okay, so the enter the new name would be Brad Pitt. So I replaced George Clooney with Brad Pitt. Now, of course, I'm not printing the list, but everything is looking good here. Also, I'm going to else print actor not present. And then also at the very end, I'm going to print my favorite actors. So now if I run the code again and I give the old name is Tom Hanks and I'm replacing with Tom Cruise. There you go. So the Python looked, was Tom Hanks in the list? Yes, it was in the list. Then it found the index where it was present. So it found the value 1. And then in that 1, it is replacing with whatever new name I gave, which was Tom Cruise. So that is how we can change the value at a given index, given of a value. All right, so that's pretty much for the scope of this lecture. And I hope that makes sense. Hello, so this is lecture 3, chapter 7, lists and tuples. Today we are going to continue seeing other operations on a tuple, but before that, I want to show you the cheat sheet that I've completed so far based on whatever we've learned so far. So in our last lecture, we learned how to use the in operator if value in list, and we did use the len function. So it's a len in parentheses. We're going to send the list as an argument. We have seen remove, how to by value, if you're given a value, use the remove method and pass the value as an argument. And I put a star here because these are all the ones that could potentially raise an exception if that value or the index is not present. So that's pretty much as far as the cheat sheet goes. So I'm going to stop showing you my cheat sheet and I want you to continue start working on your cheat sheet without my help. So let me go ahead and share and get to my lecture. All right, so in this lecture, we are going to see how to use a for loop to go over the elements of the list. So we have used for loop in 3 different ways. So I'm going to show all 3 different ways, and I'm going to say for I in range, say I'm going to give a range of elements, and I'm also going to give a step. Okay, so starting from 4 through 9, every alternate element is going to be printed if we do simply a print statement. So the for, look at the for syntax. The for, there's 4 words here and a colon. So the first word is a for, which is a reserved word, and I is a variable name that you get to choose, which will grab an element of the sequence one by one. And then the keyword in, and we've also used in earlier with an if statement to see if a value is in the list. So very similarly, the for and in are also used here. And then the fourth one is a range function. But if we look at a for loop when we were using to go over each line in a file, so remember that syntax for line in FP. So each line, this line variable would contain at any given point of time one line from the file. So it'll grab each line. So this FP happens to be the file pointer. When we open the file, we get the file pointer or the file object. So if you look at the syntax, it's the same for something, a variable name in either a sequence, and in this case, this was a file pointer. So very similarly, when we use it in a list, we would have for, and the variable name I'm going to choose is item in whatever the list name is. So if I have a list, say programming languages, that's it. 4 words, and the for loop syntax is exactly the same thing, but when I use it over a list, it will grab each item of the list one at a time. If you use it on a file, it'll grab each line of a file one at a time. If you use it on a range, it will grab each item of the sequence that the range function generates. So let's start off with this. So for programming languages, I'm going to do Okay, so if I have a list called programming languages, and if I use item in programming languages, the first time the loop goes, item stores the value that it sees first, which happens to be JavaScript. So if I simply have a print statement, if I'm not doing any kind of computation, I'm just printing the values, then the very first time it goes, it prints JavaScript. And then the next time, the for loop, and the way Python reads this for loop is until there are no more values in this list, keep reading each item or each value into this variable. So that's how Python reads this. The very first time this executes, it grabs this. The next time, it's going to look, are there any more elements? Yes, there are some more elements to go through. So then it's going to grab Python as the item, and then it prints that. So when you print this list right now, the way it is, it'll print each of the programming languages in a separate line. So that is one way of using a for loop. For loop can also be used. What if this is only printing the values? So if I ask you, what does the loop variable store when you're using a for loop on a list, you should be able to tell me the values of the list. What is the loop variable store when you're using a for loop on a file pointer? You should be able to tell me that each single line will be stored in the loop variable. But what if I also want to know the indexes where they're stored at? Not only the values, I also want to see where their indexes are. So I also want to print 0 JavaScript, 1 Python, and so on and so forth. Then this for loop is not going to be enough. There's one way to do it. You could do item dot, oh, sorry. You could simply do programming languages dot index of this item, comma, item. So this is one way to get the index of the item is simply using the list name and the index method and passing this item. You can print the indexes. Or another way to do it is using the enumerate function. So if you have a list like that, and instead of one loop variable, earlier we only had one loop variable in our for loop, and now we have index, comma, language. That means we are creating two variables, one to hold the index, another one is to hold the value. And now we're not simply using the list name, we're using enumerate function, passing the list as an argument to that function. And then whatever this function returns is going to be two values, index and language. So language will store the value, index will store the index of that value. And then when you print it, it's also going to print that arrow nice and uh well. So there are two different ways you can do a for loop to just print the values, or you need the values and the indexes. There are two different scenarios. All right, so let's see. So given a list, how can we find the maximum uh, value in a list or a minimum value in a list or the sum of all the list elements? So these are different scenarios. The only caveat is to be able to use the min, max, or sum, you have the list or the list should have all integer or float or string or boolean. So it should have all integer values, or it should have all float values, or it should have all string values, or it should have all Boolean values. That's the only way. You cannot have a mix of values. So you cannot have a float and string and want a max for that. You cannot do that. So that's the only caveat. So very simplistically, if I want scores, so if I have the scores of, say, 7 students in my class, and I want to see the maximum score, who got the max, or which is the maximum score that was awarded, then I can simply use a function, max, and inside that, I'm passing the list as the argument, and then max is a value returning function. It returns whatever the data type that your integer is your list is storing. In this case, it's an integer list, so max is returning an integer for me, and then I can print that as a maximum score. Or if you want to get the minimum score, we simply use the min function. So far the functions we have seen are len, we have seen max, we are seeing min now. So these are all the functions. The methods we have seen were append, we've seen insert, we've seen remove, and we've seen the index. These are all the methods. The difference how to use a function versus how to use a method would be a method would have the list name first and then a dot. Here, it doesn't have the list name and a dot, so this is a function call to this function called min. So when you do a min, you don't need to change the name of the variable truly. So there you go. It's printing, grabbing the least value from this list, and it's printing that for you. The last thing is the sum. So if you want to add all of these values, whatever reason, and you want to print that, that's going to be the sum scores of a list. So instead of scores, I think I could have said sales data. So if you have the sales data for 30 days and you want to see what's all the sales for that month, then that's when you would be using a sum. All right, so that is min, max, and sum. Next one is another operation that you can perform on a list is reversing a list. And the syntax is the list name dot reverse. So reverse is a method and it returns nothing. So it's a void method. So if I have a sales data and if I want to reverse this, say it's given in the order of January 1st, January 2nd, 3rd, 4th. If I want to reverse it and say I want to see it from January 7th through January 1st, then you can do something like this. Use the reverse method, and then you can print the existing. So it pretty much modified the original list. So the original list is not there anymore. We're replacing it with the reversed list. So that's how to use the reverse. And sorting the elements of a list. So if you have a list, how to sort that data again. Sorting also, you can only perform it if it's an integer list or a float list or a string list or a Boolean list, but not a mix and match. So if you have this something like that, sort is a method that you can perform on the list. So your list pretty much, the old list is gone. You cannot access this list anymore. It'll sort that existing list and you can um, all right. I think Replit is stopped for whatever reason. Let me try running one more time. Okay, Replit is having issues here. Let me pause the video. All right, Replit came back up. So if I print the list now the list scores list is not this anymore. It's a modified, which is sorted in ascending order. So when you do sort, it's by default, it's in ascending order. Um, the next thing is merging two lists. So if you have two lists, how do you put them both together? So let's take this code example and say if I have a list named 115379 and another list, alphabet psi, and I want to add those two or merge those two. So basically, this is 5 elements, this is 3 elements, and I want a resultant list that will have all these elements together and it will have 8 elements. I can use a simple plus operator. So plus when used on a string concatenated two strings, plus when used on two lists will merge them together into one single list in that order. What if I wanted it the other way? I could simply do L2, L1 if that's what I want to do, that I want these to appear first, then that's another way. So that's one way of merging two lists, that is using the operator. But if you want to use a method for it, then it would be something similar to this. So this is called a method called extend. And I don't know why it's giving okay, you cannot do L3 here anymore. And so extend method simply adds to L1. It's going to add all the elements of this other list, and it will create another new list, or it will modify the list L1. So earlier using the operator, you created a brand new list called L3, but in this case, you're modifying this list. So depending on the scenario, are you trying to create a brand new list or you're trying to add elements to an existing list? Depends on that. You can use a plus or an extend. So if you want to add elements, multiple elements, if you wanted to add one element, you used append. If you want to add multiple elements that are stored in a list, then you can use an extend method. So extend also goes this way. If you want to add the second elements to the first list, then or the first element to the second list, then you can do it like this, and you would get that in the other order. So merging two lists, and I gave you an exercise, something fun to do with, and see if you can accomplish that. All right, next thing is conversion, tuples and lists. So tuples and lists can be interchanged. So you can create a list and convert it into a tuple, or you can create a tuple and convert into a list. So let's imagine this scenario where I have a tuple, and we have not gone over tuples, but to be able to define a tuple, you have to use parentheses. For lists, we used square brackets and we gave all the elements comma separated inside the square brackets. For tuple, only the second and the only other difference is tuples, we use parentheses instead of square brackets. That's it. So if you have a tuple and you decide, oh man, I created a tuple, I got a tuple here, but I want to be able to modify it and add elements, but you cannot do that to a tuple. So what you can do is you can convert that tuple into a list and then do all the modification, and then you can convert it back to a tuple. So here, to be able to convert a tuple to a list, we simply again use the list constructor and pass the tuple as an argument, and it will create that into a list. So if you do that, so if you print T1 also using my print statement, and then also the list, so it will tell you originally that was a tuple with these elements. Now it's a new list with these elements, the same elements. So conversely, how do you convert a list to a tuple? Well, if you have a list that is these elements in square brackets, you use the tuple constructor or the tuple class and pass the list as an argument. And then when you print it, it's a tuple. So that's conversion between two data types. Now let's see how to convert a string into a list or a list into a string. That's what we're going to be using this a lot in this class for the projects. So let's take a look. So for example, we have a string named hello world, and we are asked to convert this into a list where hello is one element of the list and world is the second element of the list. So how can we do that? We use the string um, object, put a dot, and use the method called split. If you're using to take the words and make them into list elements, we don't pass any arguments to the split method. And then when we do that, now it created a list for us. The first element is hello, the second is world. What if your data has delimiters? So this is where you will be seeing. So what if we have a file that has one line of data that has all the student data in it, and the data is separated by commas. So this is the student ID, this is the student name, this is student major and GPA, each of those separated by commas, but I want to create a list element. Why do I want to create a list? Really, manipulating a string is not very simple in Python. Like if I want to change David Collins, it's really not that easy to do in Python. So what we do is we break down a string into a list, and then we do all the manipulations there. So in this case, the only difference is split method now takes an argument, a string argument, which happens to be the delimiter. If my data had a delimiter tab or a new line, I would use that particular delimiter. So when I do that using the split method, now I have a beautiful list and it has all these elements, all these data points as list elements. So, well, why do you want to convert a list to a string, Ms. Suchi? Well, I'm glad you asked. Sometimes when you're storing or when you're transmitting data to using any web application, you cannot transmit lists or any other kind of objects. It has to be a string. So that's why we convert a list into a string. Or sometimes when you're trying to print the output to a console using your printf literals, if you use, you cannot manipulate the string data of list data, but strings are easy to use with the f literal to do whatever kind of manipulation. So that's why you need it to be strings. And some libraries or APIs require you that the data needs to be passed as a string instead of in any other object. So those are three major reasons why you should learn how to convert a list into a string. And so how do we do that? So we're doing the opposite. We have done the string to a list. Great. Now take a list and convert that into a string. So you have this list. How do I convert it back to a string and use my own delimiter? How would we use the join? So split breaks a string into a list. Join takes a list and joins all those elements into one nice string using a delimiter here. So the format is slightly different. I want you to notice that part. Actually, I'm going to grab this. How split and join are different. I want you to see them side by side. So string dot and then you do the split, and in parentheses goes the delimiter, but here the delimiter goes first and then dot, and then you have the join method and employee string goes in. So try to identify these small subtle variations on how to use all of these methods. All right, so if I print my underscore string at this point, it'll give me a nice comma separated string. So I can also do my own variations. Hey, I can do a tab instead of why a comma. I can use tabs or any kind of delimiter that I choose here. See, like when you're doing a CSV, if you want to do a semicolon spaced. So this string, you can write it back to a file, so on and so forth. So that is converting from list to, we have seen tuples to list and list to tuples. We've seen strings to list and list to strings. Let's see how to make a copy of a list. So this is one of my favorite parts. Actually, I got very confused. If you're using any other programming language, making a copy of any variable is really simple. Okay. This is not a copy. This is the clear the contents. Okay, so I think I may have messed up this tutorial. I'll go back and fix it, but that's good. No issues here. All right, so if I have an employee and I want to create another duplicate copy, say emp, in any other programming languages, this is perfectly acceptable. That is perfectly okay. So if I print emp now, it'll print the same element as I have an employee. You can see the same element. So emp is technically a copy. But now if you see something else, if I do, so if I want to add a new element to employee and say salary is 70,000, right? So now to this list, okay? So my employee should not be modified. So if I print both my employee and my emp, employee should be different than emp should be different than employee because I'm adding salary to this new duplicate. But if you see in Python, they're both the same. So technically, when you do something like this in Python, you're not creating a duplicate copy, you're simply creating an alias. So employee can also now be called as emp. So any changes you make to emp will also change the original list values. So how can we create a true duplicate would be emp is equal to employee dot copy. That's it. So when you do a copy and now if you run it, then employee is my old list and employee is the new list. So this is the way, the copy method is the way that you create a true copy. A simple equal to will create an alias. All right, the next order of business is you have a list and you don't want the contents anymore, but you still want to preserve your list. Then how would you clear the contents of that list would be to use the clear method. The copy method, clear method, very similar usage here. So if you clear that, and now if you try to print employee, it will create an empty list. It will print an empty list for you. So that is how you clear the contents. Now, now there's a separate scenario where I don't want to clear the contents. I want to simply delete the entire list. I want to obliterate it. I don't want it anymore. That's when we use the del sales. So earlier, if you remember, we used the same del statement to remove an element. So if I do del sales square bracket 0, it's going to simply delete the first element. So when I run this code, it's going to remove the first element 100.45. But if I do not specify any index and if I say sales, the list name, then if I try to print it, obviously Python is going to give me an unbound local error because I just deleted a variable and I'm trying to print that. So del sales is the way to delete an entire list. Okay, so this I'm going to cover in the next lecture. That's about all that I want to cover for this. Hello. So this is lecture 4, chapter 7, lists and tuples. Today we are going to see how to do list slicing. So what is list slicing? So for example, in real life, if you're given a whole cake, but you can't eat the whole cake, you just want one small slice of the cake. How small, how big, that is something for you to decide. Very similarly, when you have a really huge list and you don't want all the elements, you just want a portion of that data, and that's called a slice. So how to be able to slice is very similar to how we had used the range function. So the general syntax would be you have to name your slice a different slice, they call it slice, and then use the list name, open close square brackets. Inside that, you can specify a start and a colon, end, and a colon and a step. So in range function, instead of these colons, we used a comma, but here we're going to use a colon. So for example, let's see, I have a whole January's data, sales data, and I don't want all of this data. If I just want a portion of the data, depending on what portion, I can specify the slice that I'm looking for. But if I wanted to print this whole data, if I want to slice this whole data and I want to get all the elements, which pretty much is pointless, but I want to show you how we can do that. So using the slice concept, if I don't specify any start, if I simply give a colon, that means Python is going to read it as 0. And then if I give another colon, which means I'm not specifying another end, um, I'm not specifying where to end, that means Python will default assume that it's going to be the end of the list. And then towards the end, if I don't specify the step, Python is going to take it as 1. So very simply, if I do 2 colons, nothing else, Python is going to print the entire sales list here. So which is also equivalent to having a 0 here, having 1 here, and also having the length of this list, January sales, minus 1. Actually, the length, because this is also like range function, it goes on to minus 1. So again, that also gives the same thing. So Python makes it very, very, very simple on us that we don't have to do in any other programming language. This is what you would be doing. But Python is like, well, if there's default, just don't tell me what it is. Let me assume. But if you want to specify, say, for example, if you want to get only the first week of data, so that would be the first 7 elements. So you can specify a 0, and then you can specify a 7, and specify nothing else. So that would be 0 to 7. And then if you run it, you'll get the first 7 days worth of data. But also, if you don't specify the start, Python will understand that it is starting from 0. So it'll give you the same exact result. So that is my slice. So if you know how to do a range function, slices becomes easy, except for these slices will be inside square brackets. In range function, we use the range open close parentheses, and inside those parentheses, we pass them as arguments. Here, inside a list, we're giving the index position separated by colons. That's the only difference, but the operation is always the same. The start and then the step is always the same. So how can we use it towards our project? So realistic scenario, where would it come for use for us? Say for example, we have our student data here. So in my data file, data folder, I have students. So in this student, if I want only, and now notice all these students are stored one line each. So I have 4 fields in each record. So this is, and I have 3 students. So how can we get only the CWIDs of these students? The first order of business, can I write all this file data into a list? Yes, very possible. I just have to give the right path. It's inside a folder, so I'm going to give the folder name, data.txt, and if I don't specify any mode, it's a read mode. And before I forget to close the file, I'm just going to go close it. And then between these two, I'm going to use a for loop. So remember, for line in FP will read each single line. So each time it'll go grab one of these pieces of data. So what my goal is, I will have to store each of these elements into a list. So before I can do that, I'm going to create an empty list and I'm going to call it students equal to an empty list. So we know how to create an empty list using square brackets, or we can use the list constructor. But here I've created an empty list. Now I'm going to tell Python, as you're reading this file, using this line variable, whatever you are grabbing, append it to the list. This is how Python is going to read it as. So it's going to read this first element and store it in line, and then it will append it to the student. So the very first time the for loop goes, students is empty, so it is going to append this value. So I'm going to break this for now. Just using a break will only let me do it one time, so we can print the students and see what's going on. So instead of just a normal print, I'm going to use my Cheatsheet print outside the for loop. If I print it, so it is going to print the first element. So there you go. It grabbed the first element and stored it in a list. So if I don't have the break, what it will do is it will append every single element. And of course, I have to strip the new line character. And I'm going to do it inside the square, inside this parentheses. I can do line, or if you're not comfortable like that, you can also do this. I would prefer it if you did all it in one method, but that's okay if you're not comfortable. So when I run it, now my list elements are like this. So each list element is now a single line in the file stored. Now, from this list, now I have students list is the consolidated list. From this list, all I want is every fourth element. So from the beginning of the list, grab only the fourth element. So how can we do the student ID slice? Student ID slice is nothing but students and start at the beginning. So I'm not even saying 0, I'm saying start at the beginning and then read to the end every fourth element. That's it. From the beginning to the end, get me every fourth element. And this time, if I print the student ID slice, let's see what that's going to be. So there we go. We got the student ID slice. So this is what we can use later on for our calculations to get the next student ID. So again, this is the simplistic code that we can write, but also remember that this has the potential to raise an exception. So I want to see this in a try block. So the read goes in the try, and then I have to write an except cause. So what happens if an exception is raised? I'm going to say print file doesn't exist or something, file error, whatever, and else will have everything in this block. So basically this block is nothing but this entire function. So everything will go inside the else block, and that's it. So now I have added exception handling to this scenario. And so where is the best usage of this is, what if I wanted to add a new student, but I don't want to ask the user for an ID? I want to look at the existing IDs and find the maximum ID and then add one to it. Just increment and get calculate instead of asking. So now that we have the student ID slice, how can I get the maximum? We've already done that. We can simply get the max student ID is equal to max function will give us that value from this slice. So right now, this is the slice we're looking at. So when we do the max and we print the max student ID, what's going to get printed is just the 1003. Okay, now I have 1003. The next student will be 1004. I simply have to add 1. But the problem is if you add 1 to it right now, it's going to add 10003. Well, actually, if you're trying to add an integer value, a string plus an integer is not possible. So we are going to convert it to a integer. So right now, my data type is a string, right? So I have to convert that into an integer. So max student ID in the string form, please convert that into integer form and call it max student ID. Why not? Call it the same. And then to this, the next student ID would be max student ID plus 1, right? So that's the max student ID plus 1. Now, if I print the next student ID, I get what I want, which is an integer 1004. But you know what? I need the string 1004 because when I want to write it back to the file, I cannot write an integer. So I can simply do all my conversion inside here. And then next student ID will be a string data type instead of integer. Again, instead of using 4 lines of code, you can do it all in one. here, the max student ID here is nothing but the integer value, but max student ID is nothing but the maximum of the student slice. But student ID slice is nothing but student 0004. So if you don't do any of these and you do just that one line, everything in one line, you still get the same output, string 1004. So that is how we can calculate the next student ID. We've incremented an existing student ID. So that is a realistic application of slice, and I've given you a try and see how that works out for you. So that's pretty much all I wanted to cover in this class, list slicing. Hello. So this is the lecture number 5 in chapter 7, Lists and Tuples. Today we are going to see list comprehension. So what is list comprehension? Before we go through that, let me go share my screen. And if you've already forked the REPL, please go ahead and fork it again because I've changed some code. So I'll take a second here and I'll pause the video until then. All right, so I am going to fork the REPL. This time I'm going to give it a separate name and call it lists and tuples 2. So we're going to look into list comprehension. So list comprehension is not so much a method to manipulate the list or change the list or delete, none of the create, update, modify, delete, but this is more of writing code in a concise way that Python expects us to. So this is a very, very friendly way of doing it. So let me get on that. All right, so list comprehension is a very simple expression. It's a concise expression. It does the exact same thing. The code is exactly going to function the same way. It's just going to look differently. So for example, instead of explaining what it is, I'm going to demonstrate what it is. So if we have a list like this, and if you notice, each element has a tab character at the end. So what if we are asked to create a copy of another list that will not have these tab characters? So basically, we're supposed to use a for loop, and we're going to strip off or use our strip method to remove the tab character, and we know how to do that. So let's see, without comprehension, how would we accomplish that? So first of all, we will create another copy of a list, and we're going to create an empty list. And then using a for loop, and we're going to call it element in student. So we're going to go over every single element of this student, and then we are going to strip off the new line character or the tab character, or strip slash tab. So now our element doesn't have these tab characters anymore. So now I can easily append each of these elements to the new list. So if I did that, and if I simply did a print copy, it will show us the list without tab characters. So there we go. But instead of using these 4 steps, there's a very concise way in one statement. Again, the functionality will be the same. Python will still have to go over each element and strip off the new line, the tab characters, and append it to a new list. But as an end user, we will not have to look at this much of code. Our code will be pretty simple. So how do we accomplish that? So for list comprehension, first grab the list that you're trying to create, like a copy. Okay, but before I can do that, let me just go ahead and do these 2 statements in one statement. So what is element? Element is nothing but element with the tab character strip. So I don't need this code anymore. So these 3 lines of code, I'm going to consolidate in one line of code. The first order of business is grab that first empty list statement. So this is going to be the new copy you're creating. Then the second order of business is to get the for loop without the colon. Copy it just as it is, and then place it inside the square brackets. And now to the left side of the for loop, you're going to place everything that goes inside the append statement. So whatever is in the append goes here. That's it. That's as simple as that. So if I comment out this code, and if I run it, it will exactly show the same output. So this is called list comprehension. We're writing it in a very comprehensive way. So let me show you another example, and we have done this for our students. So where can we realistically use an approach like this is when we have our student data. So we're trying to read a student file, and then we were stripping the new line characters. Remember that part? While we were creating a student's list, when we're reading file from the data and putting it in a list, we were stripping off the new line character. So let me remove all these comments out. This is for future. If you ever want to go back to the tutorial, you can read these comments, but for now, we don't need all that. So I'm going to remove the list using list comprehension as well. So without list comprehension, we needed these 4 lines. And of course, I can accomplish these 2 in one statement. Okay, so we have a minimum of 3 statements that we need to accomplish writing file data into a list. So when you see that, each of these elements will have, well, we stripped off the new line characters. So how can we accomplish this in one? So first, like I said, grab your empty list. So it has to be a list because we're doing list comprehension. Of course, you can do a dictionary comprehension and a set comprehension later on, but right now we're seeing list comprehension. The brackets have to be square because we're creating a list. So the second order of business is get the for loop, place it inside the square brackets, and then to the left side, you want to grab everything that is inside the append. So it'll take a couple of times for you to get practice this and get better at it. And in one single line of code, you are done. So basically, we can go back and edit all our previous code that we've written, and it should work just fine. Oh, this is an else block. So there we go. So I have given you a couple of try this. The more you try, the better you're going to get at it. So there's another variation is in list comprehension. So what if we have an integer list like this and we are asked to um, create another list with all even numbers from this list for whatever reason. Okay, so what are we going to do? Realistically, as a programmer, we use a for loop, and while the for loop is looking at each element, we're going to test it to see if this is an even number or not. If it is even number, then we're going to write it to a new list, append it to the new list, and if it's an odd number, we're just not going to do anything about it. So how would we do that? So for item or element, whatever you want to call it, in int list, that's the name of my original list. Again, before I do my for loop, I need to make sure I have an empty list to have these new elements. So I'm going to call it even equal to an empty list. And now I'm going to go over each element, so each item. So I'm going to have to test if 3 is an even number. How do I do that? I can simply say if, and 3 is going to be captured in item in the very first iteration, and divide or the remainder operator, we're going to use that, and divide it by 2, is it going to give us a 0 remainder? That's all. So this will tell me whether a number is even or not. So if it is an even number, we're simply going to append it to our list that we had created earlier. That's it. So now we have 4 statements. So before in the case that we've seen before, we never had any if, but now we have an if. So when you have an if, how would you write your list comprehension statement? Again, the first couple of steps, first 3 steps are actually going to be the same. First, grab your future list that you're planning to have new elements in, and then get the for loop without the colon. That is going to be the same. And then to the left side, you want to get whatever is inside the append method and space it. And then to the right side now, you're just going to put your if without the colon. And that's it. And as simple as that, we have created the whole list. Instead of 4 lines of code, we have 1 line of code. So if you print it now, even number list will only have the even numbers, and the replit is still executing it. So there you go. It's grabbed all the even numbers. So how about you want to create an element or a list between with elements between 5 and 8. So that's where this is where you would change your code and say if item greater than 5 or greater than or equal to 5, whatever your requirement is, and item less than or equal to 9, if that's your requirement, and remove the equal to 0. So your conditionals will be on the right side. So, and then if you run it, everything between 5 and 9, including 5 and 9, will be in your list. So there you go. So get a little bit of practice. If you need to, write a for loop first, like you're used to, and then do your list comprehension. So that is pretty much all I wanted to cover in this chapter. And there's one remember me here, and I may not have it here, that list comprehension will always return a list. So this expression will always give a list. So that's about all I wanted to cover. Hope that makes sense.
So this is chapter number 7, Lists and Tuples, and the lecture number is 6. And we are going to see tuples and multidimensional lists in this lecture. So let me share my screen and get started. So we're going to start off with multidimensional lists. So when we talked about lists and the data types that a list can contain, we said lists can contain any data type, including a list and a tuple. So when you have a list inside another list, it's called a multidimensional list. So if to make it more visual, I'm going to break my list down into something like this. So you can see that we have 5 elements in this list. And the 5th element is not just a primitive data type, it's actually another sequence that happens to be a list. So basically, I'm storing students' data inside a list, and the last element is storing scores all in one list. So we know that we can access a list element using its index. So if I want to access any of these data elements, I simply use their positive index or negative index. But how can I access each individual element inside this list's list? So that is kind of the point of this lecture. So if I use my module, Suchi underscore print, of course, I may have to import that module. So let me go ahead and do that. My module's name is Suchi print import Suchi. Right. So when I print it, it'll print me a nice nested way, if it can. All right. So again, I think I may have to fix my module here to not do that. So let me fix my module first. So this is the reason why we encourage the Pythonic way standard convention to do if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore. And then inside this if block, I'm going to call the main. That's about it. Close that one. And now if I run my code, it is going to execute and it's just going to show my nested list. So basically my list is not a flat list anymore. Now it has dimensions. So the 4th index, or which is the 5th element, is a list, and each of these list elements is an integer. So now to be able to access these individual lists, so for example, if I wanted to get the second score of this student, so first order of business, what would I do? First, I need to get the scores. So to be able to get the scores, just by looking here, it's 4, the index position is 4. So I can print all the scores. Hey, that's fantastic. But I can print all the scores, but how about I access only a specific score in that list? So that's when I would use what's called a second index. So when you have more, as deep as your list goes, you would have to use more indexes. So the second level index would be, if I wanted the second score, that would be found at index position 1. And if I print that in the second set of square brackets, I can access that element. There you go. So I accessed just that element that I'm looking for, and I've given a closer look, and I kind of broke it down, and I created multiple variables. But here in this lecture, I'm just going to show it all in one. So given another example, so this is the realistic example we're going to be using in this class is, what if we had multiple students stored in multiple lists? So for example, I don't have just one student, I have 2 students, and then both of those students are in 2 separate lists, and I'm trying to use that in one big consolidated list. So each student formatted in this particular way. So each student will have their ID, name, major, GPA, and scores. And this is student number 2 in the same format. Now I'm creating another list. I'm saying list because I'm doing square brackets. Inside these square brackets, I'm saying student 1 comma student 2. So I have 2 elements, and each of these elements is a list, but inside that list is another list. So this is a 3-level deep list. So this is a two level deep list because it has a list inside a list, but this one is a list inside a list inside a list. So that's quite it's not really difficult. It kind of could get overwhelming, but it's really simple if you use my module to print it out to see how the list actually visually looks like. So let me go ahead and do that. So in this case, for example, if the objective is to get John Decker's GPA. So if the user wants you to print John Decker's GPA, first of all, John Decker is where? Let me just print it out and show you. Printing it, that's the problem. So if I print students, it's going to print a list with 2 elements. And inside that, we have another list and inside that there's another list. So if I want John Decker, I know that I can find him at list position 1, index position 1, but I don't want all information about him. So I only need to go find where is his GPA. So in this one, if I look for 3, so I have to use 2 indexes to get his GPA. So that would be 1 and 3. And that's it. If I do that, I'm going to simply get 4.35. That's an invalid GPA. We'll fix that. All right. So if the objective in this case is to get James Smith's third score. So where is James Smith's in my list? According to that, it'll give me index position 0 is where James Smith is at. All right, so I don't want all of James Smith. I want his third score. So to be able to get to his score first, I have to access what index position is the scores stored, is that list stored? And inside that, which one is the third score? So now I'm going 3 levels deep. So this will give me all of James Smith. This will give me all of his James Smith scores, and this index will give me his third score. So this is if you practice a few examples, it'll start getting better and easier. This is what we're going to be doing for our project. So all right, so moving on. So I've given a try this for you. Try that and see if you can get it. So tuples. So we have seen lists. So we're going to see another sequence called tuples. And like we talked about, tuples are very similar to lists except in two scenarios. Number one, how to declare or initialize a tuple for Python. And the second one is lists are mutable, but tuples are not. So once you create a tuple, you cannot modify that. So you might ask, if tuples are so similar to lists, why do we need another sequence? Why can't lists do the job? The only thing that I can tell you is lists come with a lot of overhead because lists are supposed to be elastic. So there is a lot of overhead on Python to create a list to be able to add more elements. But if you create a tuple, Python uses so much less overhead because it knows the tuple doesn't change. It is not going to change. You cannot add or delete elements. So that's the difference. So for example, when can you use a list? You can use a list when you know the data is going to change. So for example, for a student scores, you can add more scores because as the student is taking more exams and assignments, you will have to add new scores, right? So that's when you would use a list. But if you want to store the sales data of January 2023, that is not going to change. You only have 365 days or 364 and 366 days depending on the year, but that's it. It's not going to change. So it's a historic data. So that's when you would use a tuple that would reduce the overhead. So anyway, so like I said, there's only 2 differences. Number one is how to create a tuple. So I'm going to try to compare and contrast between a list and a tuple. So if you want to create a tuple, you use the tuple class and tuple. For list, we use the list class. For tuple, we use the tuple class, or you can simply use parentheses. So for lists, we use square brackets, but for tuples, we simply use parentheses. So if you print it, my print statement will simply say it's a tuple because it's an empty tuple. So that's how you can create a tuple, an empty tuple. One other difference between lists and tuples is how to create an element with a list or a tuple with one element. So if I wanted to create a list with one element, this is how I would do. That's all I have to do is square brackets and that element, and then it'll create an integer list with one element. So as you can see, it's identified list and one element is 89. But if you want to do that to a tuple, you cannot simply place parentheses and try to print it, and Python will tell you that, hey, that's not a tuple, it's an integer. Because you're placing it in parentheses, Python simply ignores those parentheses. But if you want to force Python to believe it to be a tuple with one element, then you must place a comma. And that's when Python will know, okay, I understand your intention. Now I'm creating you a tuple with one integer element. So that's the third difference. That's all. Those are all the differences between lists and tuples. So pretty much everything else is the same. How do we create a tuple with elements? Well, instead of square brackets, in compare in contrast to a list, we're simply going to use parentheses and comma separated elements. And just like a list, we can have any data type in a tuple also. You can create all integer tuples, all float tuples, or string tuples, or a mix and match. And you can have a tuple inside a tuple. That would be a multidimensional tuple. So you can have multiple data types in a tuple. Those are all similar, and you can create tuples similar to the range function we've seen in list, except for you use the tuple class instead of the list class. And the repetition operator just works the same way that it worked in lists. And tuples are also ordered just like lists. So I'm not going to go over all of that. So accessing elements using index. So just like we were trying to access index elements in list, putting the index positions in square brackets, we would do the same thing. But because tuples are using parentheses for their declaration here instead of square brackets, does not mean we have to use square parentheses here. The index accessing is always going to be square brackets, no matter you're using a list or a tuple. So identify that just because we're declaring a tuple using parentheses here does not mean you can use parentheses here. So the index element accessing is also going to be similar, and negative indexing also is available in a tuple. And let's see, accessing a tuple using an index value is also done. And in operator in tuples operates very similar to that of a list. You simply use the in operator using an if statement to see if an element or a data item, so it has to match, the case has to match if it is a string, and you can simply use the tuple name and a colon, and then you can do whatever operations you want to on that. And for loop is also very similar. If you want to use just get the value, you can simply use the name of the tuple for the loop variable name. In the name of the tuple will give you the values of that tuple. If you also want their indexes, you can also use the enumerate function and pass a tuple as an argument instead of a list. And enumerate works both with lists and tuples. And then enumerate will also print the index. The for loop is going to be slightly different, where you'll have two loop variables here if you're using enumerate. So that's similar. And some tuple functions that we have seen very similar to list are len. So you can calculate the length of a tuple using the len function. You can also calculate the min, max, and sum, just like we did, very similar to what we did. And we're going to do max and min and sum. But when we come to tuple methods, this is where tuples deviate very significantly from lists. So in tuples, because tuples are immutable, we cannot use an append. Append literally meant we're adding more elements at the end, but tuples are immutable, so we can't add, so we can't do that. Sort is pretty much rearranging elements, and it gets performed on the list itself, but tuple cannot be modified in this case. You have to literally destroy it and create another list to create a sorted version. So sort or reverse you cannot perform on tuples, but you can do a roundabout way where you can convert a tuple to a list perform a sort or a reverse, and then you can convert it back to tuple. We've seen how to convert a list to a tuple, and we have also seen how to convert a tuple back to a list. So tuple has pretty much only two methods available. Number one, it has the index method, where you can get the index of a given value. So if a tuple has some values, you can pass any value and tuple will return what is the position of that value in the list. So if I simply print t dot index, name of the tuple, and we give the value, say let's say 68, it's going to find the very first occurrence of 68, and it's going to tell me 1 because index position of 2 is 1. So it works the same way as it did in index, in lists, and the only other method available is count, and it returns the number of occurrences of an element in a tuple. So instead of index, if I were to give count, and instead of 68, maybe do I have 78? If I give it 78, it's going to go over this list and see how many times is 78 occurring in this list. And in this case, it's 2, so it's going to print that. The tuples are easier to remember because there's so much less you can do on the tuple. And the operators on tuple are very similar to that of a list. And the only operator that's going to be different is the equal to operator. So if you want to make a copy of a list, how did we do that? We simply we use the copy method, because when we were simply using an equal to, it was creating more like an alias than a copy. But tuples don't have that problem because you're not going to be modifying that list tuple in anyways. So a simple equal to will create a copy of that tuple. And plus operator merges two tuples. We cannot use the extend method here because extend method operated on a list. On a tuple, you cannot do that. So you have to take two tuples, merge them, and store it in a separate tuple. So that's how plus operator works similar. And star operator to create a repeated tuple also works the same way. Couple more operations on tuples that we can do is how to delete a tuple, just like we deleted elements from a list. No, we cannot. Just like we deleted an entire list, we do the same thing. We simply give del and the name of the tuple, and it'll delete the tuple. But conversely, when we were seeing lists, if this had been a list, we were able to also say del, and we could give a position, and it would delete that element at that position. But you cannot do that in a tuple. Of course, this index doesn't exist. That doesn't exist. So if I try to del tup2, even though there's index position 2 here, I cannot do, because remember, tuples are immutable. Once created, you cannot modify it. You cannot add more elements. You cannot delete more elements. You cannot insert any elements. So that's it. And tuple slicing works the same way as list slicing. Multi-dimensional tuples also work the same way. Only thing, or good news for you or bad news, I don't know, comprehension is not possible on a tuple. So one less thing to do with tuples. That's pretty much all that I wanted to cover in this lecture. So I hope that makes sense.